Friends, today we will start our first chapter from mechanics, and its name is mechanics. In mechanics, we will see the compound pendulum. Friends, up to this standard, we have discussed the simple pendulum, bar pendulum. Now, in this class, we will see the compound pendulum. Now the question arises here that why we having a necessity of compound pendulum. See, there are some drawbacks in simple pendulum as well as in the bar pendulum. And to avoid that drawbacks, the scientists have been invented the another type of pendulums, that is compound pendulum. Compound pendulum is nothing but a rigid body which is capable of oscillating freely about a horizontal axis, and that horizontal axis is passing through that body, and the time period of that compound pendulum is given by t equal to 2 pi under root of I into under root of I upon mgl. See, where I is nothing but the moment of inertia about axis of suspension, m is its mass, l is distance between the point of suspension and center of gravity. See, for getting the idea of a compound pendulum, there are two important points, two important we can say center of suspension and center of oscillation. As per the theory, see, S is the point of suspension, means that we are passing the axis to suspend the pendulum is called as point of suspension, and that point of suspension is perpendicular to the plane of the paper. And see, friends, G is nothing but a center of gravity. Now what happens? The body is displaced through a small angle theta over with the CG, and we get a new position of CG. The couple acting on the body in mgl sine of theta, and it try to bring the body towards its mean position. See, friends, this is nothing but the diagram. In this diagram, you are able to see here is the center of suspension, and here is the where the pendulum oscillates, center of oscillation. Its length is L, and oscillation given through the angle theta. And the couple produced by this pendulum by the oscillations is nothing but the angular oscillation in the body, and it is given by d omega by dt. This couple is also equal to I into d omega by dt, where I is the moment of inertia of the body about an axis which is passing through the point of suspension and perpendicular to the plane of the paper. See, for getting the expression for the time period, we know that I into d omega by dt equal to minus of mgl into sine of theta. Here, friends, theta is a very small, and therefore sine of theta is we will take the theta, and d omega by dt by in this side we will take I, therefore it will be denominator minus of mgl upon I into theta equal to mu into theta, where mu equals to mgl upon I is a constant. See friends, d omega by dt is directly proportional to the angle minus theta. This equation 1 shows that the angular acceleration is directly proportional to the angular displacement. This is the angular acceleration, the omega by dt, and that angular acceleration is directly proportional to the angular displacement. And you see friends, here the negative sign indicates it is directed towards the mean position and opposite. Hence, it is nothing but a simple harmonic motion SHM, and the time period of for SHM t equals to 2 pi under root of L by mu, and C it is nothing but 2 pi root of mu, that is a I upon mgl. This is equation number 2. Let we will see the I0 is the moment of inertia about an axis passing through the CG, and G is the parallel to the axis of suspension. By principle of the parallel axis we can write I equal to I0 plus ml square, and see friends, I equal to mk square plus ml square. Here the k is nothing but the radius of gyration, and therefore the equation 2 means this equation again becomes t equal to, by putting the values for the I, that is m k square plus l square upon mgl, and by solving it we get t equal to 2 pi root of k square plus l square upon gl, and that is nothing but t equals to 2 pi, here this l, that is k square by l plus l upon g. The equation 3 is a required equation for the time period of the compound pendulum, and the equation 3 is equation for time period to time period for simple pendulum, and it is given by t equal to 2 pi root of L by G. Now comparing the equation 3 to this equation, we find the length L equal to k square by L plus L, and this factor is known as length of equivalent simple pendulum. Since k square, therefore k square is always greater than 0, the length of equivalent simple pendulum is always greater than L. Now friends, up to this we have discussed the compound pendulum. Now the important property in concern with the compound pendulum is interchangeability of center of suspension and oscillation. See how this, see now in the diagram the center of suspension and center of oscillations are shown. G is the CG, then a point C, the point O lying on the other side of CG is known as center of oscillation. The axis passing through this and parallel to the axis of suspension is known as axis of oscillation. Now see the pendulum be inverted and suspended about its axis of oscillation through O. Then its time period is given by, again the formula, t equal to 2 pi root of k square L square dash and GL dash. But here k square L equal to L dash, or k square is nothing but the L dash, and hence by putting these values we will get t equal to 2 pi root of L dash plus L square dash upon GL dash, and finally by solving this we get T equal to 2 pi root of in bracket L plus L dash upon G, which is the same as the time period about the center of suspension through S. And we are going to draw an arc with a distance equal to k square by L and G as a center. Then we get point Q and O. Also point equal to distance of a point S. Point S means nothing but a center of suspension from CG on the other side. We find that when Q becomes a point of oscillation, P becomes the point of suspension. Yes, P is a point of suspension. Q becomes point of oscillation. Hence, S, P, O, Q, O are the 4 points collinear with the center of gravity about which time period is seen. See now, these are S, P, S, P, Q, O. These are the 4 points which are collinear with the center of gravity about which the time period is same, and therefore friends, here the important thing that in concern with the compound pendulum, the center of suspension and center of oscillations are interchangeable, means that if we are getting a time period for center of suspension, then we get an equal same time period for the center of oscillation. Thank you.